Welcome to the Statistical Power and Effect Size page of Research Engineer. Ask the question, within the current empirical or clinical context, are you measuring for a relatively small or large effect size? In my experience as a statistical consultant, this is the hardest part of planning a study, is an a priori power analysis to yield an adequate sample size based on a hypothesized effect size. The size of your effect has a pervasive impact on your ability to conduct a study. The majority of researchers that come to me, and I say about 99 out of 100, have no idea whatsoever what type of effect size they're trying to detect in their research. So what I tend to tell them to do is to go back to the literature, find a study that is theoretically, conceptually, or pathophysiologically similar to what it is that they're attempting to do, and use the means and standard deviations and proportions that are reported in those published studies. This is called using an evidence-based measure of effect. This adds internal validity to your study and also shows more empirical rigor on your part to have sought out the highest level of evidence to use in an a priori power calculation. In other instances, when you moved into an entirely new realm of science and you can't find any articles in the literature regarding what it is you want to study, then it's best to conduct a pilot study, collect between 150 and 300 observations of the outcome, and see what happens in regards to the hypothesis that you want to ask. And in these pilot studies, regardless if you find statistical significance or not, you can use the means and standard deviations or proportions from a pilot study in a post hoc power analysis that can tell you exactly how many people you'll need to collect to detect a significant effect. When your effect size is measured at a continuous level, then the effect size is the absolute difference in means and standard deviations between the independent groups in a between subjects design, between the observations of an outcome in a within subjects design, or a difference in the association in a multivariate design. When the outcome of interest is categorical or nominal, the effect size is the absolute difference in proportions, odds, or risk between independent groups in a between subjects design, across multiple observations of an outcome in a within subjects design, or adjusted beta weights and distributions in a multivariate design. The magnitude of an effect size is the actual size of the effect. If you are using categorical outcomes in your study, it is the percentage difference between independent groups or across time with multiple observations in a within subjects design. If you expect one group to have a 50% proportion on an outcome and another group to have a 25% prevalence of the outcome, then the absolute difference between 50 and 25 is an effect size of 25%. When using continuous outcomes, the magnitude is the absolute difference in means between independent groups or within subjects. So if you hypothesize that the pre-test score average will be 75 and that the post-test score after an educational intervention will be a 95, then your treatment effect is 95 minus 75 for an effect size of 20 points. Defining and operationalizing an effect size as being either small or large is done within the current clinical or empirical context. Small effect sizes will always require larger sample sizes, and large effect sizes will always require smaller sample sizes. Scroll down here and click on the small effect sizes button or the large effect sizes button to continue in the Research Engineer statistical power decision engine.